Hello, this is a brief lecture on Android and the use of the camera. There's a couple sites here that you can click on in the original PowerPoint of this lecture, which is found on our class outline. But if you're not there, you can directly type in these URLs. So, of course, the first thing to note is one of the hardware features on most all Android devices are the existence of a camera or sometimes multiple cameras. And here you can see a few of the really creative things that people have done with cameras. Of course, this is kind of featuring some of the gaming sites that are out there. First thing to take note of is, as with any kind of hardware feature, you need to, in your Android project, ask for permission to use the Android feature, and this is what you would have to add in your manifest file. So there are two options for using the camera. The one is to simply call the existing camera application on Android devices through an intent, and to launch it, return back to your application when the picture's been taken. That'll work if you're only taking a single picture, something along those lines, and you don't really care to, it's all right with you to go ahead and quickly launch to the other app. The other option is to create your own camera controls inside your app to take a picture. And of course, this is generally most desirable, and certainly if you're going to do anything beyond taking a single picture, something that you would need to do, not just want to do. So, of course, depending on which option, the code will be different. We'll be looking at some sample code a little bit later. The first one, we're going to be using an intent, and there is an intent action type called action image capture or action video capture. Option 2, it depends on the API that you use. Before API 21, there was a series of classes that were used, like camera, surface view, and media recorder. And the new package since API 21 is Android Hardware Camera 2. So certainly the easiest way, if you don't mind launching into the camera app that exists on devices, is to create an intent to launch it. So certainly it minimizes the code, and it's good when you don't really need any camera controls. So there is a nice link here to a developer website that shows an example. But basically what you're going to do is you're going to compose an intent using the action image capture, action video capture. You're going to go ahead and start the activity for results using this intent, because you do, of course, want to get the image or video. And then you're going to receive the intent results with on activity result that you need to implement. So again, with option 1, you need to add these lines of code into your manifest file. So specifically, you're going to be asking to use the camera. You are using the feature of the hardware camera. And then, since you are going to be taking a picture or video, you need to store it somewhere. So writing is something else that you need to do to storage. So let's look at a simple example. This is called Camera Simple Activity Extends Activity. So it's an activity. We have some static variables here when we want to do an image activity set to 100 or set to 200. And similarly, we have a media type for image equal to 1, media type for video equal to 2. We'll see how we use that a little bit later. And then the location of where the image or video will be stored will be represented by the URI object called file URI. Okay, so in onCreate, this of course could be done somewhere else based on, let's say, a button being hit to take a picture by the user. So wherever you want to actually launch the event, you go ahead and create the intent. This is what it looks like, new intent. And in this case, we're going to say we want to capture an image. And then we create a file URI associated with the actual image. And then we put the location, that file URI location, and we put it associated with the extra output names. This is like a name value pair that we're adding to the intent. And then we start the activity for results with that intent. And we need a corresponding on activity result method that we need to implement. We're going to override, because this is where once we launch to the camera app and the picture is taken, it will return here, or if it's an image, a video. So the first thing this returns is the initial request code. And so this is testing whether we had requested to take a picture, an image, or alternatively if we had taken a request for a video. If the results were okay, that means we successfully returned from that intent, that camera app. Then what we're going to do is we're going to display just a simple success tag here. If it was canceled, then we're going to say the camera was canceled. And finally, if it failed in some way, we're going to say failure. Similarly, in this case of the video, we're going to just say where the video was saved, and we're going to print it out. Okay, so we have some methods here called get output media file URI, which is going to call get output media file, which is the next method based on the type. Okay, so if it's external storage, in this case, we're going to get the environment, get the external storage public directory. The location of where pictures are stored is called the directory pictures in the environment, and we're looking for the subdirectory called my camera app. So if for some reason that directory doesn't exist, we attempt to make that directory right there. If that fails for some reason, we have to fail and return null. So the file that gets returned is null. Otherwise, if we were able to either find that directory, it exists, or create it, if it didn't, we come in here and we're going to create the name of the file that we're storing it in. And so we're going to say that we're going to grab and create an instance of a date. We're going to format it like this: year. So like 2016, month would be like 10, date would be like 22 _ hour, might be 08, and then minutes and seconds. Okay, so this is just a timestamp in this format of the current date when this program was run. So this is a local variable called media file. If we're creating an image, we take and we grab that media storage directory that we created before, we get the path, we add a file separator, and then the name of the image is img _ that timestamp that we created, that string .jpeg. If it's a video, it's pretty much the same thing, except instead of img _ it's video _ timestamp.mp4. And this is going to go ahead, and then we're going to return this media file here, which is an instance of the file class that we created, and that we're going to use. So when you run it, this is what happens. Of course, this is being run through the emulator, which, interestingly enough, the emulator will actually, if you have a camera on your laptop, will use that as your in your emulator as emulating your device's camera. Okay, continuing on. So returning the results in this case, it was a success. So when we launched it, basically the activity directly, if you remember going back here, in onCreate, in onCreate, what it did is create that intent to launch the built-in application, and it started it right away. That's why what we see when we run it is immediately the camera app, because it runs so quickly. And then the results, in this case, everything was a success. This is what we see here when we go on activity results. If we requested the image and all the results were okay, then we just had the text view, so it's success. Of course, the image actually exists, and where it exists is in the location specified by the directory for the pictures. There'll be a subdirectory called My Camera App, and in there will be a file called img_timestamp.jpg. So if you were to go to the Android monitor, the device monitor, and take a look at, browse through the File Explorer and see the data, you would see that file existing there. You could also find it going through the Pictures camera app as a saved and taken image. So suppose you want to actually load that image from the file that you specified. So that's something that I want to talk about how to do. Another thing that you can do is actually the intent returned from the camera app has a small version of the image bitmap that has been taken. And if the small image is sufficient, then you can use it directly. So I want to talk about option one, where you're going to go ahead and load that image that's been saved to the file. So I have a method called setPictures that gets invoked maybe based on some kind of user event. And the first thing we do is we have a widget here. So there's an image view widget called mImageView. That's a class variable of the activity. We grab the width and height, because the width and height of my view object may be different than the width and height of the actual image that's been taken. So we basically need to kind of map one into the other. Okay, so we're going to get the dimensions of the bitmap, and this assumes that the mCurrent photo path is the location of the image that you took. Okay, and you could build that out, that name, from saving it as a class variable, for example, right here. So when you're returning the media file, you can save it as a class variable called mCurrent photo path. So we're going to use a new class called Bitmap Factory, and we're going to create an instance of options associated with the Bitmap Factory. So bitmaps are exactly that. They're two-dimensional maps of bits, and that is actually what a picture is. It has pixel values in a two-dimensional grid, so we're going to use this factory to help us get the information. Okay, so we're going to go ahead and, using the Bitmap Factory's static method called decode_file, we specify the path and we pass the options. And the only option that we set is in just decode bounds. So it's going to read in within the bounds of the image size the image that's been stored. From this we get the actual width and height of the image, the picture that's been taken, and we're going to determine the scale, which basically is, that's like saying if you were to take the actual width of the photo and divide it by the target width, if that's greater than 1, right, then we're basically going to take and we're taking a large image and shoving it into a smaller image view, and same thing with height. So we want to find the minimum of those two, and that's going to be used as our scale factor. So now we're going to change our options, and we're going to say this is a scale factor, which is called the sample size, and we're going to create a bitmap. using the bitmap factory. We're going to call decode file again, now with the new options. And then all we have to do is using the returned bitmap that we've gotten here, we're going to go ahead and call on the image view widget that we have, the component image view, that object. We're going to call the set image bitmap and pass it the bitmap, and it'll be displayed. So the second option is to actually know that when you return from the camera app being launched, it will actually return a small type icon sized image. And if that's appropriate, if that's large enough for what your needs are, then you can use it. So in this on activity result, if you're requesting an image and the results were okay, then you can call this method here. I'll talk about it below, but what you're passing it is the received intent that you've gotten. So this handle small camera photo takes the intent that you've gotten, grab the extras, and one of the extras is the actual data associated with it, the image data. This is a small icon type image, and we convert it to a bitmap. And then wherever you want to display it again, this is a widget, an image view widget. You can set the image bitmap to that new image, and it will display. So going back to before, we talked about the fact that there are two ways for you to have a picture or video taken. One is using the external camera app, which we just went over. Another option is for you to create code so that you control the camera directly inside your application. You never leave your application. So this requires, of course, the use of API classes. And if you remember before, there are two options. I'm going to kind of go back a number of slides. We talked about the fact that depending on whether you use before API 21 or after API 21, you will use different classes. Okay. So first, let's go back. We're going to look at prior to API 21, which uses a number of classes. One of them is called camera, and this is the primary class for controlling the device's camera. A surface view can be used to look at live camera preview, and then the media recorder is used to record video from the camera. Okay. So there is a method of the camera class called getNumberOfCameras, and that's interesting to note. A lot of devices have more than one camera. They might have a rear-facing and a front-facing, in the case of most tablets and phones. And so knowing how many you have is good. The steps you need to do is to detect and access the camera, decide which, of course, camera you're using, the front or the rear, depending on what your application wants to do. Create a preview class to basically view the currently captured scene, and that's with a surface view class, which implements a surface older interface. You're going to build a preview layout. Once you have the camera preview class, you're going to basically incorporate it into your layout with whatever controllers you want. Set up listeners for capture. And then you're going to capture and save files, and then when you're done with that, you no longer need a camera control. You need to release the camera. That's very important. It's kind of like releasing a file when you're writing to it, or releasing a database when you're connected to it. So another app will have access to it, the camera. So detecting if the camera is, detecting if the camera is there or not. There is the context that the application runs in that's being passed to this method called here check camera hardware. If that context has the feature, basically feature camera, okay, so it's the whole line is context.getPackageManager.has system feature PackageManager.feature camera. If that's true, then the device has a camera, and if not, it returns false. Okay. And if you want to find out more, please take a look. You can click here on the original PowerPoint or go to the Android Developer API and take a look at Package Manager. There's something that goes over that has a system feature method to see. Read more about it. Okay, so if we know that's true, one of the things that you need to do next is to get a camera instance. Okay, an instance of the camera class that's associated with the camera you're going to use. So in this method that we're creating, we define a local variable called C, which is an instance of the camera. We use the .open static method of the camera class, which will return an instance of camera associated and open, ready for connection. If there's any exceptions, you'd want to handle it here, but otherwise we're returning that camera instance. So if there's more than one camera, you can access specific cameras by calling the open method with an integer. In the default open method, it will return the back-facing camera if there's more than one. So an optional step is that you might want to get parameters associated with the camera or get various camera info related to the camera, like, for example, the resolution it runs at and things along those lines. Okay, and I'll have you take a look. You can go to the Android API and read about camera parameters to see what's supported. So we want to create a preview instance because we're going to have our own controls. So you need to see like the live view of what the camera is seeing so that the user can then determine when they're going to take a picture or whether they're going to start and stop a video if that's the case. So we use, as I mentioned before, the Surface View class to do that. The code next, what we're going to see is how to create a basic camera preview class that can be included into a layout, and it implements also an interface called surfaceholder.callback in order to capture callback events. Okay. All right, so we have some various import statements as you might expect, and here is our class called camera preview, and it extends Surface View as I promised and implements the interface surfaceholder.callback. Okay, so we have a local variable, class variable here called mholder. We have a class variable called mCamera, and here we have our constructor. Our constructor takes an instance of the context it's running in and the camera. After calling the parent, which we know is the Surface View class, right? The parent's constructor, we initialize the camera to the camera that's specified here. And then we take and we are creating our class variable here called mholder by calling getHolder. Okay, and then we register the callback for the mholder as this class, because again we're implementing, as shown here, the surfaceholder.callback. Okay, this is deprecated setting, but it's required on Android versions prior to 3.0 if you're running something older, which that's pretty old, but you need this line of code. Okay, so some of the things that you have to actually implement as part of implementing the callback is some of the methods that we're going to see here, like surface destroyed, surface changed, and here's surface created. Okay, so we're referring to, the surface view here. Surface created is going to be called when it's created, and we're basically going to tell the camera where to draw the preview. So again, the camera is the mCamera object. We say mCamera.setPreview display holder, and the holder is being passed in here. And then we call start preview. And what start preview does, if you read in the Android API camera classes, it actually starts the live video of seeing what the camera sees being displayed. Okay, if this particular camera preview, which is a view object, is going to go away, we basically have to, if the camera is not null, stop the preview. So it stops trying to update the preview service. If the surface is changed in any way, then if the surface is null, we don't do anything. But otherwise, what we're going to do is we're going to try to, again, stop the preview. And we're going to go ahead and pass to mCamera. We're going to call the set preview display the M holder, and we're going to start the preview again. Okay, so we tried to stop, and then if you want to make any rotations or changes, you can, but you're going to restart this with the surface being changed, like maybe from orientation, maybe from the size, those kinds of things. So step 2, more on orientation of the app. Camera preview doesn't have to be in landscape mode. Starting in Android 2.2, you can use the set display orientation method to set the rotation of the preview image. In order to change the preview orientation as the user reorients the phone within that surface change method, you first have to stop, change the orientation, and then restart the preview. And that's what this is about. It's changing. So it could change based on rotation, going from landscape to preview. You could test that, but that's basically right here. If it's a rotation, okay, then you're going to do the rotation. Otherwise, as it's resizing, you're going to redo the resizing. That code is not shown here, but that's what you would do here. But what I'm showing here is a stop, make your changes based on the change of the orientation or change in the size, which you can query directly from the context. And then here, we're restarting. So let's take a look at an interface. This is a linear layout. Inside there is a frame layout with a button here. Okay, so the frame layout is not visible, but it's filling the parent, and it has an ID called camera_preview, and that's what we're actually using to display. That's the image preview. Okay, so this particular code specifies a horizontal layout, and that's typical in camera controls. It's typically horizontal. It doesn't have to be, but that's what's specified here as it being landscape. So you can see that's this right here, the horizontal, the linear layout. And so here's our camera activity class, and the activity for your camera view. In there, you're going to add your preview class to the frame layout element we saw before. So here's in onCreate, we're going to grab our camera instance, and then we're going to say new camera preview, right? And that was the previous class here that we went over. Okay, so let's go back. We're going to create an instance of that associated with the camera. So we pass the activity, we pass the camera to the constructor. Then we grab the frame layout instance associated with the ID camera preview. Let's take a look at that. Here it is, frame layout camera_preview. That's the ID. And then what we're going to do is we're going to say for that frame layout instance, which is called preview, we're going to add the view M preview. Okay? And again, that's the camera preview instance that we declared here and that we created right there. Okay, so great. We have this live thing going associated with our camera. How do we actually take a picture using it? With the camera object that we have, that class has a method called takePicture. It actually takes 3 parameters. It receives data from the camera, and to get data in JPEG format, you have to implement a picture callback interface to receive that image data and write it to a file. So let's take a look at that, how we would do that. Okay, so add this code to your application activity class. Here we have a class variable called mpicture equals new picture callback. And this is an anonymous inner class that we're defining. We're overriding the method onPictureTaken, which will be the callback function. It's going to receive the actual image data as an array, a one-dimensional array. And what that actually is, like the first row of the image, the second row of the image, the third row, fourth row, going all the way down. So, and then of course, here's the camera associated with having retrieved that data. So the first thing we do is we call, we create a local variable here called picture file, which is associated with the location. Remember our get output media method that would build out for the image type based on the current date timestamp in the pictures directory. It would give the name of that .jpeg, right? Okay, so if it doesn't exist for some reason, then there was some kind of error, we get the error message and we return. However, if the picture isn't null, we're going to grab a file output stream and we're going to write the data that we received in this callback, right? So the image data comes in again in that one-dimensional array. We're just going to dump it all out into the file and then we're going to close it. And all the formatting for JPEG and all of that will be contained in that byte, that one-dimensional byte directory called, array called data. Okay, so that's great, but we need to go ahead and then do some kind of event handling so it takes the picture. So we had a button called button capture. Let's take a look at that back in our layout. Here it is called button underscore capture. So that's right here, button underscore capture. And we are going to create an on-click listener for it, again, anonymous. And we're going to create a new instance of it. And we're going to override on-click. So that when basically that button is clicked, it's going to call the mCamera.tapePicture, and in this case it's going to say null null, and the callback is that mPicture, right, the mPicture instance right here in our activity class. So when this button is hit, it's going to basically call the take picture, which we know will go off and take a picture, and then the data will be returned to this callback method called onPictureTaken, which will write it to the correct file. Okay, so releasing the camera is very important. So, this might be done at the end of the life of the activity. It could be done based on launching to a new activity. It really depends on what your application does when you want to call it. But whenever it is that you're done, call camera.release. You should do it right away because it does capture the camera resources. You don't want to be holding onto the camera and not allowing other apps to use it. So create a simple interface with a button that will trigger taking the picture. Here we go. This is that create picture. I'm just kind of showing you step by step. And here is the entire activity class. There's more on other slides, so we can't fit everything on one slide, but here's the onCreate. Here's our button, right, our camera button, and we're registering the on-click listener so that in this case it's going to call camera lab 2 this and call the photoshoot.class and start the activity. Okay, and here's our on activity result, which again, depending on if the results are okay, it's going to get back the input associated, the bitmap, and associate it with the image view to display it of the picture taken. Great. Oops, sorry, there we go. And here's the photoshoot class, okay. It extends activity and is also a surface holder callback. So this has the onCreate method in here. We're doing some various things with the window We're making it translucent with no title, and so on. Bunch of imports. Here's the permissions that are associated with that manifest file. Okay. And if there are some optional ones that you may be interested in using, like autofocus, you can take a look at those. All right, so some of these are optional. You can obtain an instance of a camera with Open. You can grab parameters. If you're interested, you can set parameters. You can set the display orientation. You have to make an surface holder to set the preview display up. Start the preview. When like for example, the user clicks on a button, you can take the picture and then, receive in the callback, wait for callbacks to actually process the image data. We've seen how we've displayed it. After taking the picture and processing it, you might want to then recall start preview again. And then when you're either done with the interface, you would call stop preview and, very importantly, release.